It's pretty wild to think about. A little over 100 years ago, a simple paper cut could actually kill you. Today, we have drugs and technologies that are straight out of science fiction. So, how did we get from there to here? You'd probably guess it was a slow, steady process, right? Well, not exactly. A huge chunk of what we call modern medicine was born in one incredible 50-year sprint. Let's dive into how that amazing transformation really happened. Okay, let's just paint a picture here. Imagine walking into a doctor's office in the year 1900. It's probably a quiet room, and the doctor's relying almost entirely on their personal experience, their intuition, and honestly, a fair bit of luck. Now, fast forward just 50 years to 1950. That office is gone. Instead, you're in a place buzzing with technology, lab tests, x-rays, people talking about specific viruses and bacteria. It was a complete revolution, from an art based on hunches to a science driven by hard data. So the big question is, what on earth lit the fuse for that kind of change? So what was the first big domino to fall? Well, it all kicked off when the very heart of medicine shifted. It moved from the patient's bedside and went straight into the laboratory. It is just incredible, the power of a single idea. Once germ theory really took hold, it wasn't just an idea, it became the idea, the guiding principle for basically everything. For the first time in history, medicine had a clear enemy you could name. Doctors could finally understand that a specific sickness was caused by a specific little invader, a pathogen that you could actually hunt down, study in a lab, and most importantly, target. And you can just see the ripple effect that one idea had. All of a sudden, we get the tools to see the invisible world inside us, things like blood tests and x-rays. It gave doctors a kind of precision they could only have dreamed of before. And this whole scientific turn gave birth to brand new fields like virology and microbiology. It totally rewrote the curriculum for medical schools. A doctor couldn't just be a healer anymore. They had to be a scientist too. So the lab provided the whole foundation, but another force, a much more violent one, came along and acted like a massive supercharger for all this progress, and that was global conflict. It's a really tragic irony, isn't it? But World War II acted as a huge accelerator. I mean, the sheer scale of that war created these incredibly urgent needs for things like trauma surgery and blood transfusions on a level nobody had ever seen. And to meet that demand, governments had to step in, pouring unbelievable amounts of money into research. This created a powerful new engine for innovation, an ecosystem that linked universities, hospitals, and big industry in a way that just never existed before, all of them laser-focused on one goal. And the poster child for this whole wartime engine? Penicillin. Now, it wasn't a brand new discovery, but the war created the desperate need to figure out how to mass produce it, and the impact was just immediate and staggering. It was a true miracle drug. It saved countless soldiers from infections that would have been a death sentence just a few years earlier. But more than that, penicillin was proof of concept. It showed the entire world what this new model of state-funded, crisis-driven science could actually accomplish. And the success of penicillin, well, that kicked off the single biggest revolution to come out of this entire era, the age of antibiotics. Just look at this timeline. The pace of discovery is it's breathtaking. Once penicillin threw the floodgates open, the discoveries came one after another. In less than 10 years, humanity went from being almost totally defenseless against bacteria to having a whole arsenal of weapons. Think about that for a second. The things that had been killing people for basically all of human history were suddenly being defeated. What used to be a death sentence was now becoming just a treatable illness. This incredible success created this fascinating pivot for the entire field of medicine. Once doctors finally had the tools to fight back against infectious diseases, a whole new set of challenges started to come into view. The main battleground shifted. It moved away from those old enemies like pneumonia and tuberculosis to a brand new frontier: chronic illnesses, things like heart disease, cancer, diabetes. Suddenly, the job of medicine wasn't just about surviving an infection, it was about managing your health over an entire lifetime. But here is the thing. This golden age wasn't all sunshine and miracles. The same breakneck progress that was saving lives also created some really complex new social and ethical problems. And that brings up a really critical question. With all this amazing new science changing the world, who was actually getting access to it? Well, as it turns out, that answer was complicated. The science was just moving at lightning speed, but our ethics, our ethics were lagging way, way behind. In the middle of all this excitement, whether or not you got access to these new miracle cures often depended on your race, how much money you made, or even just where you lived. And in that desperate rush for the next big breakthrough, the rules were often just ignored. Horrific experiments were conducted without anyone's consent, and vulnerable people were tragically exploited, all in the name of so-called scientific progress. So one of the first real attempts to build some ethical guardrails was the Nuremberg Code back in 1947. It laid out basic, common-sense principles, like informed consent. But what's really telling and kind of shocking is how slow everyone was to adopt it. A lot of researchers at the time, especially in the US, just didn't see it as something that applied to their work. It's a really stark reminder of the huge gap that had opened up between what science could do and what it should do. And that leaves us with a question for our own time, doesn't it? Because the dilemmas from back then, they haven't really gone away. They've just changed their shape. As we push into new frontiers like genetics, AI, and biotech, we're facing the exact same fundamental challenge. How do we make sure our progress serves everyone ethically? That incredible 50-year leap taught us some really hard lessons, and frankly, we're still working to fully learn them today.